now that we've learned some basic ideas like radian measure and how the measure of an angle relates to the circle and to the degrees or the unit of measure going around the circle, we can now take a look at a common trig application called the unit circle. Now, what the unit circle is basically a circle that has a radius of 1. And in using that radius of 1, we are able to actually come up with values for any point on the circle. So if you look at this little visual off to the right here, you can see that we've created a right triangle to a point on the circle with a radius for 1. Now I've taken the time to actually draw this a little bit bigger so that you can see that basically we have the central angle, and of course we don't have drawn here, is the XY axis that was created. But basically we have X and we have Y to get to that point, and of course that circle is kind of coming around here like that. Now what we can do, since we have created a right triangle, is actually take some of our old rules like SOHCAHTOA and figure out the sine and the cosine and the tangent and all of their reciprocals of this particular triangle. And what you notice here is when you take the sine of theta, you end up getting the opposite over the hypotenuse, which is simply y. Same thing with the cosine of theta, you get the adjacent over the hypotenuse, which is simply x, which is our ordered pair. So really we can actually replace our ordered pair with the cosine of the given angle and the sine of a given angle. Now this is significant, or this is important, because there are quite a few special angles that we know the sine and the cosine of. Most specifically the 30, 60, 90 triangles and the 45, 45, 90 triangles. And so what we can do is we can actually create a set of ordered pairs all the way around the circle for the different degree measurements or radian measurements that we worked with in the prior lesson. So this is a very important concept for you to understand, understanding sine and cosine of the particular angle equaling the coordinates on the circle. So if we go back to our notes, you can see that as a result of this, that if we applied the Pythagorean theorem to this triangle, we would actually end up getting an equation that says x squared plus y squared equals 1, which is technically our radius squared. And what you're going to find out later when we start working with conic sections is that's the standard form for the equation of a circle, and that's a result of this right triangle. Now what happens here is we're able to get the sine and the cosine, but we also can take the tangent and the other trig functions and create the given values. So in sample problem number 1, what we want you to do is continue to define the remaining trig functions on the unit circle for any given angle. And you can use this right triangle that we've created here to do the rest of them. Now, whenever we get into the actual working with the unit circle, we will look at something that looks like this, where you have to fill in the different ordered pairs for the given angles. And so you can see that at 30 degrees it gives us a certain ordered pair. Well, the sine and the cosine from those were actually done in lesson 1, and so you should have this information somewhere in your notes and be able to use it to fill in the given unit circle. So this is a very important circle here for you to learn all the moving parts to. It's not something that I expect you to memorize per se, but just get to learn by working with it. So let's take a look at this first sample problem. Go ahead and try to fill in the rest of the given information for the trig functions. Okay, if we look at the triangle, what we'll see is that the tangent is going to be the opposite over the hypotenuse, which in this case is y over x. Cosecant, which is the reciprocal for sine, is going to be 1 over y. Secant, which is the reciprocal for cosine, is going to be 1 over x. And cotangent is reciprocal of tangent, is going to be x over y. So that's a good start. And using this information, we'll be using this information to work further problems.